about different ways for how we actually collect information to analyze. So if we can just get everyone's quiet attention here at the front. We've looked at a lot of different information and data and done kind of different types of analysis throughout this unit and made different types of graphs. But we're going to see, again, how can we get that information in the first place. And so the question for today is, who are the best lyricists in hip-hop? The Roots are an American hip-hop band. They're currently the house band for The Tonight Show. And a recent vocabulary analysis of hundreds of hip-hop artists put them right here near the top. One other measurement to compare artists' lyrical ability is their average word length. And so in our lesson today, we are going to find the average word length of the song The Fire, which is written by the Roots. Now you'll see that you have the lyrics to the song right here in front of you. So that was on the little white half sheet that I had you grab on your way in. And I'm going to have you go ahead and complete step one. You're just going to quickly circle a random sample of 5 words and write your 5 words here in the space below. Now what you're going to do next is part number 2. You're going to find the average word length for the 5 words that you chose. So I have a little example actually over here on the side. So my 5 words that I picked in my quick sample were the words challenge, love, hear, sports, and I. And what I did is I just counted up the letters. So off to the side here, I listed how many letters were in each one. And I added those up. I got a total of 29 letters total. But then I divided that by 5 because we're finding an average here, and we had 5 words. So my average word length was 5.8. So I would write a 5.8 on the line. So go ahead and do that for your 5 words and figure out your average word length. All right, so once you find your average word length, you're going to go ahead and check in right now with your group. And you're going to ask them, what was their average word length? So compare for all the people in your group. And you're going to see if theirs was the same as yours, was it different from yours, why or why not? Did anyone get an average word length that was the same as their group? Was it different from your group? Why do you think it was different? Arno?
Because we could have all picked different words.
There's a lot of words to choose from, so there's probably a high likelihood that out of everybody in your group, it was probably 5 different words, not the exact same 5 words for every sample. So it totally makes sense that we would get different values. So when I checked this with some people in my group earlier, I saw that we all had a different average word length. So they were not the same because every sample is different. All right, so what we're going to do next here is go ahead and transfer the dot plot best we can from the poster in the back right here onto our paper. So if you're close to the back, you can turn and look at the plot. I'm going to stand back here and make it to show up on the screen up at the front. Okay, so we are now going to do this process again. We are going to find a second sample of 5 words, but we're going to utilize a different approach. We are going to instead use a random number generator to see if we can make the next sample a little bit more random. And so you'll notice, I haven't really seen anything yet. I need you guys to open up random.org. It's just a nice, easy website here to navigate to. So this is the random number generator that we're going to use for the next part. So I'll bring it over here on my screen, random.org. And to get a random number, a random value, we have some places where we can type numbers in here inside of this little purple box. And this would be like, if we wanted to randomly pick a number between 1 and 100, it's giving us the option to change that end value if we have more than 100, which we will today. So I'm going to give you here in just a moment this green paper that has the actual same song lyrics as the other paper, but you'll see that each word is listed out individually. They're listed in columns here, and every single word is numbered. And so it's going to continue on the back side as well. There's actually 456 words in the song. And so we're going to want to change our maximum value. Instead of picking a number from 1 to 100, we need to change that to 456. That's how many possible words we have to choose from. And here's how this is going to work. So when we hit generate, it's going to give us a random value. So it's the top number here that you see in bold. So mine was 344. So what I would do here on a green paper is go ahead and find the word that is labeled the 344th word, and it's the word not. So I would probably like to write these down just to have a list of what my new 5 words are, and then we're going to find the average word length again for your new sample of 5. So I'm going to go ahead and give these green sheets out here to the person in the front of each row. All right, so this is our clock for the second type of sample that we did that involved that random number selection process. So now I want you to go ahead and answer questions 6 and 7. So looking at a comparison between the two, how is the new dot plot different from the first one? Which one do you think is a better estimate of the average word length of the song, and why? And then once you've done that, go ahead and answer part 7. What do you think the true average word length is for today's song? All right, so let's come back together here. So starting off with the first part of the question, like what is an obvious difference here between the two graphs? Go ahead, Jake.
So like the first one's really spread out, and then the second one's kind of.
Yeah, so it looks like we have this like really difference in spread. If we look at kind of like that range from the highest value to the lowest value, this one's a lot more spread out. This one seems a little bit tighter, a little bit closer together. What else did you notice? What's another difference between the two graphs?
The second one's closer together.
Yeah, so kind of visually how it looks. What about where the actual dots are? Do the dots seem like they're in a kind of different place? Yeah, so it kind of looks like overall, from the first one, we like have a lot more dots that have a higher average word length, like over here on the right-hand side, whereas it kind of seems like these ones, sort of on average, was it was like a lower average word length. So the actual positioning of the dots is an interesting difference to notice. Which one between the two do you think is a better estimator of the true average? We vote on the first one or the second one? Second one, lots of people are saying this one down below. Why did you choose the second one? A lot of people said that. Go ahead, Jacob.
Because, like, when you're picking a random word on here, the bigger words take up more space, so you're more likely to pick them. But when it's just a random thing, it doesn't matter what someone's actually typing because it's random.
Yeah, so it was a different process for how we picked our words. We see that these words look like they're a little bit shorter because really every word had an equally likely chance of being chosen from that random number generator. And so some of these longer words here, it could have been like our eyes were more drawn to a longer word. Perhaps we were looking for more interesting words. Like I picked the word challenge, which has 9 letters, versus like the word to, or the, or me, that we might think, well, those are just kind of simple, ordinary words. They're very short and small. So when we were just kind of quickly circling the 5, although it might have been fast and convenient to get the 5 words, we saw that overall they were a lot higher. And when we give every word an equal chance, we see, well, overall, it ends up being shorter, but this is really probably a better estimator because we don't have any sort of bias in the way that they've been chosen. And so what do we think the true average word length might be? If we were to find the true average out of all 456 words, what's a guess at something you think it might be close to?
5.7.
4.
4.
5.7, I don't know about that. It's like not even, so if this is the one that's kind of supposed to get us a better estimate, yeah, I agree with you that we're kind of thinking like our center visually looks like it's probably somewhere around 4. We have a lot of values like on top of 4, but that kind of seems like that's where all the values are centered around. Well, you all were very close, most of you. We're close because the true average word length of the song was actually 3.88. And so let's go ahead and label that here. I want us to actually label that on both of our dot plot pictures. And we'll kind of see what we notice here. So the second way of getting our sample, I'm going to give this second dot plot a name here. So this was the result of taking random samples. We saw that random sample process was actually a much better way to get an estimate of the truth. Now the one that we did up here, I'm going to actually give this one a different name. So let's label this one. We'll call it a convenience sample. It was really quick, it was fast, it didn't require us to take all the time to number the individual words. That might have taken some extra time, but what we're seeing is that the convenience sample led to results that had very high bias. Almost every single one of our results was higher. It was an overestimate of what the truth really was. And we can see that the true value here for all the words in the song, it doesn't really seem to be the center of the first dot plot. So since it's so far off, it looks like it would just tip over. We say it has a lot of bias. It wasn't a good estimator of the truth. All right, we're going to add in just a couple additional notes here on the front side, and then we'll talk about summarizing some of our big ideas here on the back. So our first learning target today was about understanding the difference between a population and a sample. So I want to go ahead here on question 1 and just label that the first set of 5 words that we selected, actually the second set as well, we would call that a sample. It is a smaller size of individuals from whatever the larger population was. Now, in this case, the population would have been all 456 words in the song. Whereas our sample was a lot smaller, much fewer amount of words. It was just these 5 words. Now the first average that we figured out from our first sample of 5 words, the one that we have listed here on the line, let's go ahead and label this. We're going to call this a sample mean. Because it's a mean, it's an average that comes from a sample that was taken. And the symbol that we use for a sample mean is the X bar symbol. We saw that a little earlier on in the unit. From our calculator, that's what we use when we have a sample mean. Now, our second learning target here says we want to understand that estimates based on random samples will display sampling variability. So that's what we're seeing right here in question 3. The fact that your sample mean was slightly different from the other people in your group is an example of sampling variability. If I can fit that word in. So every individual sample taken was slightly different from the next. All right, and then finally on our dot plot picture, so we talked about and labeled the sample mean earlier. What I told you here, that 3.88, that is not a sample mean. Instead, it was the population mean. So that was actually taking the average length for all 456 words. And here's just kind of a fun fact, a little something interesting, is that when we're dealing with a population mean, we're going to use a different symbol. So we don't actually use the X with a little line on top. We use another symbol. It's a Greek letter, and the way we say it is mu. And how it looks is, it looks like kind of a U shape with like this little extra tail in the front. So if we were to go ahead and label the 3.88 on both of our pictures, that's the correct symbol that we would use. All right, when you're ready, we're going to go ahead and turn over to that. All right, so going back here to learning target number 1, the difference between a population and a sample. So I'm going to draw a visual of a population. I'm going to put this inside of a really big, kind of bubbly cloud. And our population could be a lot of different things. Today our population was all 456 words in the song, but it could be actual individuals. It could be actual people. It's kind of like whatever is the group that we're wanting to gain information from. And so our population could be like all the students at Monarch High School. If we wanted to get information about the students that attend the school, our population could be like all the citizens of Louisville. It could be all adults that live in the United States. So as you can see, a population has the potential to be quite large. And so if we want to gather information about these individuals in the population, we might find it to be challenging, take up a lot of time, or maybe cost a lot of money to get information about every single individual. In fact, if we did that, it's called a census. And that's why we only do it every 10 years. It takes time, it takes money, it's a lot of work. And so a faster way to help us instead gain a little insight about the population is to take a sample. And the key thing with taking a sample is we want it to, first of all, be smaller in size. So I'm going to make this small, but we want it to look like the population. So I'm going to make another little cloud bubble around that. We want it to be kind of equally representative of the individuals in the whole thing up here. So let's just write off to the side here. The whole thing with taking a sample from a population is just that we're going to be able to use a sample to make inference, which is a way to say, like, draw conclusions about a population. All right, our second learning target was about understanding that estimates that are based on random samples will display sampling variability. So that's just this idea that each random sample will give a slightly different estimate. So today we saw that each random sample of 5 words gave us a slightly different average word length. All right, and then our third learning target here is to describe a population to which results can be generalized based on the sampling method. And what we saw today was the power and the benefit of a random sample. We saw that that gave us a pretty good estimate of the true value. Well, a random sample should be representative of the population from which it was sampled. So if I was wanting to get information about all of the students at Monarch High School, and I decide to take a sample, suppose that I go and I stand up at the library entrance door, just down the hall from here, and it's just a book club is ending. So as students are leaving, students from the book club are getting into the hallway, I'm just going to start to survey and ask questions to each of those students that are leaving. So that's how I choose my sample. Well, that was quick, easy, pretty convenient for me to do. That would be a convenient sample. But the thing is that the results I get, I'm not going to be able to generalize them to the population of all Monarch students because there was only one type of student that who might have similar thoughts or opinions as one another. I don't really have equal representation of everyone. And so in that case, if I have a convenient sample, well, I might be able to generalize my results to students of the book club, but really I would need to have a random sample if I wanted to generalize my results to everybody in the whole school. So although it might take a little bit more time, what I would really need to do would be like get a list of every student who attends Monarch, put a number next to their name, pull out my random number generator. I'm going to select 30 students or 40 students, however many I'm looking for, track those students down, ask them my survey question, and then my results could truly be generalized to the whole population. So we're going to have a chance now to kind of think a little bit deeper about some of these concepts from today in our Check for Understanding. We've got a different context here about a curious student. Well, they're wondering about the average height for all students in their school. So the student selects a random sample of 40 students, measures their heights, and then calculates the mean height to be 65.2 inches. There are 5 questions here down below. That scenario, so I want to give you a few minutes here to think through each one of those and just record your thoughts on your paper space. Good job. So I heard some great conversations here. So so if we were to do a different sample of 40 students, it's not necessarily, we're not going to get exactly the same result. Every time we have different 40 students, it's going to be a slightly different mean, and that's another example of that sampling variability. Now, if we were to look at our sample mean of 65.2 inches, even though we get a random sample, it doesn't mean necessarily that that is going to be exactly equal to the true mean. This was just a sample of one set of students, kind of like what we had back there, like on the random sample, not every single value is exactly equal to 3.88. The idea is that the more times we do this, it's going to be close to that. 3.88 might kind of look like our center, but it doesn't have to be exactly the same. All right, and then we had some interesting statements down here below. So we wanted to decide if it'd be reasonable or not to make the following claim. So first one, it says, I am confident that the mean height for the sample is 65.2 inches, yeah, that's reasonable to say. That was the average that we got for our sample. Wording slightly changes here for Part B. I am confident that the mean height of students at my school is, here's the key word, close to 65.2. Well, that will also be reasonable to say, because since our sample was a random sample, it should be representative of all the students at the school, so it's probably going to be somewhat close to whatever we got from our sample. Now let's look here at Part C. It says, I am confident that the true mean height of all high school students is close to 65.2 inches. Well, not necessarily. We only have information from students at our school. We don't have information from students at all the other schools. So you cannot generalize to a population that is beyond the population from which you actually picked your sample. All right.